Hello folks. So this video will focus on refactor life, and I did not do it before, so I've started to record videos. I mean, at least this video and coming videos, that I record my attempt and then just trim the important sections and put it together and upload it to YouTube. So yeah, let's see what it is. Refactor life. Refactor a convoluted object-oriented game of life implementation. I already have downloaded. If you want to get this in, subscribe to CS Primer. It's a good thing, and get it there. So I did not run this yet, and let me open my terminal. Zoom out and drop it down. Here it is. So let me run how it is. Okay. Okay, so it's running some iterations and some amount of width. And what if I do like 200 and 250? Mic check, mic check. Okay. Okay, that's too wide, and I would say 50. 50. Okay, that's fine right there, but 50. Okay. The rendering is anyway, that's game of life. I seriously don't know how that works, but let's try refactoring this. So this is about refactoring. So in terms of classes, there's this one, and there's this, there is that, neighbor counter, grid, and cell. And cell is a state, false is alive. Okay, pretty smaller chunk. It's just a static method. It takes a width, takes a height, takes iteration, initializes game of life, and runs it. Okay, so this is a redundant one. What we can do is copy this, paste it here. Now, is it a static method? It is, right? So it's the same thing. Well, it's a static method. We don't, I mean, it's fine, because instead of run game, we'll do, is there run game anywhere? Okay. Yeah, we don't be needing this. Run game, game of life, yes, width, height. That's right. So now game of life. So let's try that out. It's working. We got rid of this extra class. That's basically a wrapper to initialize something and run. Now let's dive into game of life. So there's a grid. The grid is width and height. So let's jump into grid. Okay, so width, height, it's a cell. Now cell is a state, is alive, returns state, set state. Okay. for width, for height. Okay, it's a 2D grid. Get cell, set cell. Okay, that seems fine. And uh, do we need a separate cell? I mean, this provides, I don't know why my cursor is moving down, but this provides a good APIs, despite what it is underneath the state. I think my mouse is jumping there, but he is alive and set state. Although it's very basic, okay, but this seems fine. And you get a get cell, okay, set cell, set state. Okay, this looks fine for me. I'm not sure what kind of refactoring can be done there. But here's a neighbor counter, which is a pure function, uh, though it's in class. It takes grid and xy and it counts. I mean, there's a counter. So -1, so up, right, down, and left, and edges. I mean, all these combination. So it will try to get that cell, and if it's alive, it will return that count. Okay, we don't need this. Okay, so we'll get back to it when we encounter this neighbor counter. And then there is rules. uh, Rules. Okay, so now we are done with the grid. I mean, grid looks like a good abstraction. We will not take that in and put it here. Now there's neighbor counter. Okay, so let's see where the neighbor counter occurs. Self dot neighbor counter dot count neighbors. Self dot grid. Okay, that only occurs once. It only occurs once. We'll just extract this out, and we'll make it as a class method. I mean, object method. Get rid of the static method because this is bound to self. And when there's a grid, it's self dot grid. We are binding the inner state of the object, and self dot grid dot get self. Okay. All right. So there's some formatting which I don't like, but okay. Now I made a change. Neighbor counter, right? So yeah, so I will safely comment this out and try running this. Neighbor counter, where is this? Line 69. It's just count neighbors, sorry. 4 were given. We don't need to pass grid. Looks like it's running. Let's move on. We can get rid of this code and neighbor counter. Bye bye. Also, rules is just a simple method. There's no state binding. It takes a cell and neighbor count. If cell is alive, okay, and if, okay, some rules, either 3, if the neighbor count is exactly 3, or that's like a little weird. Okay, only if the cell is alive. Okay, all right. I need to look up how this game of life works, but rules is getting initialized here. Rules is getting initialized here, and the rules is getting called where. So cell is not a primary state of this class, so that's why it's accessing cell. And neighbor count. Okay, and we don't need to grab the neighbor count. We can just call the neighbor count. Wait a sec. Okay, so I'm gonna copy this. So neighbor count cell is alive. Let it be for now. Let it be a static method. Of course, we'll try what we can do, but no need of separate class for this. I mean, it's good that there's a separate rules class. I mean, okay. So the rules, you don't need that. Now wherever the error occurs, which is the rules, yes, apply rules or game of life dot apply rules, and you pass on cell and neighbor count. Essentially it's computing. Let's see if it works. Looks like it's working. So okay, now this state is a separate class, which in turn is a cell and a grid. Okay, is alive, cell state, set state. Okay, yeah, it looks good to me. So let's see. uh, Now that's game of life, initialize random. Some probability, you can set probability for, okay. So okay, you are cell dot create set cell. Set cell. Okay, now let's go to set cell. Self dot cells set state. Okay. Get cell x y. Okay. It's just a wrapper for a bunch of cells. And it looks good to me. I don't want to put it together. I mean, it's good enough. Now step. New grid equals grid. Okay, so alright. They are not modifying straight up, so they are creating a new grid. And once they do the step, they are mutating the inner state. So for x in range self dot grid dot height weights. Okay, you get the cell, get the neighbor count, new state, you apply the rule. Okay, neighbor count. Now neighbor count, and new grid set cell, new state. Okay, I guess there's a room for refactoring. Again, it's tangled up in classes, but we can uh, move this into apply rules, count neighbors, uh, neighbor count, apply rules, neighbor count for a cell. Right now, what is neighbor count to? Right, so xy is directly related to cell. uh, the cell's position is unknown. Okay, you just maybe call xy, maybe call xy, and you can silence this off. Let's get that. Okay, wait, new state, neighbor count and cell. Now cell, apply rules. Okay, so the cell is self dot grid x comma y, and you need a neighbor count. Neighbor count is self dot count neighbors xy. Okay, now you return the new state, so you don't have to worry about that, so that line is not needed. Self apply rules. Okay, now this is not a static, now it's a self bound. This would be self dot apply rules. Okay, it's never used, you don't need that, maybe just comment out for now. Okay, looks like it's running. Now we can get rid of these. Yeah, for okay, new state apply rules for xy, and new grid set cell. Okay, yeah, looks fine. I mean, looks fine. Step, run for iteration systems dot clear set display step sleep. Okay, so it's just a rendering function, no need of windows. Count neighbors, I think. Okay, one sec, what can we do here? So display static method run game, and game dot run. I mean, I didn't have to like put it here, or all the bunch of things into one, but it's okay. I felt it's okay. So this is a display function, this is count neighbor xy, so now it's just doing grid get cell is alive. Okay, it's computing something. I mean, it looks good, looks good for me, and it's fine. Apply, okay, that is also fine. We just moved some bunch of calls to self apply rules, and made the apply rules to refer the internal state. Then I mean, it was a pure function. uh, Yeah, testing would be to set state first and then test each functions out. Okay, which is the thing that I don't believe in. Again, I'm going in class way, but I believe in functional way. uh, New state, okay, you get the state, and new grid. Okay, so you're not modifying the current grid, which is good. uh, I mean, that is how it is, because if you mutate whatever that you would calculate for the next, it will affect. So essentially you are transitioning into a whole new set of states, and then once you're done computing everything, and then you modify the inner state. Looks good, looks good. Yeah, looks good. I mean, this looks good for me, so I need to see the video and see what better I could have done here. That's it for the video, and thank you.